Hello, let's continue our Sudoku adventure with Cirquoise by Marty Sears. This is actually Marty's debut for a Sudoku adventure, so welcome, Marty. Thank you for becoming a Sudoku adventure setter. So this is a puzzle in our Counting Circles theme week. Yes, I remember what I'm saying. So every puzzle this week has counting circles, and then all of them also have, except for the first one, have an additional constraint. So let's go over the rules to this one. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have counting circles in the grid. So if a digit appears in a circle, that is how many times that digit appears. I know it sounds confusing, but if I put a 3 in any of these circles, that means I have exactly 3 threes somewhere in the circles. I can't have 2, I can't have 4, right? I need to have exactly 3. And then if I have, say, a 1 in the circles, that means I have exactly 1 in the circles and no more. And you got to fill all the circles, obviously, because you got to fill every cell in the Sudoku. All right. We also have these turquoise lines. I think that's why this is called Cirquoise, which is a portmanteau of circle and turquoise. So these are same difference lines. So every pair of adjacent digits on a turquoise line has the same difference. So if this was, say, 2, 4, that is a difference of 2. So now these two also need to have an exactly difference of 2. So I could put a 6 here, or I could put a 2 here. I will point out that 0 is a valid difference, but I don't think that's going to be valid for any of these lines because we can't repeat digits here, we can't repeat digits here, but figured I'd say that if you ever encounter same difference lines, 0 is not excluded. But I don't think that was mentioned in the rules because I don't think that 0 is actually possible on any of these lines, so it doesn't matter. Anyway, those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, we're going to start by counting how many circles we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 circles, and I need 4 distinct values. Well, remember we learned from the last puzzle, but I'll go over it again, that because whatever digit I put in a circle appears exactly that number of times in the circle, that is counting how many circles there are. Every unique digit, if we sum them up, is going to be the count that is going to sum up to the count. So in this case, the unique digits that I put in the circles add to 11, and we know there's at least 4 unique digits. But 4 is the maximum number of digits that can add to 11, and it has to be 1, 2, 3, 5. That's the only way to add to 11. Because 1, 2, 3, 4 adds to 10, we got to add 1 to that, but the only digit we can add 1 to without repeating a digit is the 4, so we remove the 4 and make it a 5. So we are going to need 5 fives. Circles are in all 6 boxes, but they are only in 5 rows and 5 columns. So every row and column needs a 5. This row has only 1 circle in it, so it's a 5. And now every remaining circle needs a 4 and a 5 in it. So this is a 4-5 pair. No, we don't have 4s. Sorry. I almost made a mistake there. So what are we saying for 3s? Okay, we can't have any more 1s. I'm trying to see if there's anything. I mean, we could obviously put 1, 2, 3. So we can put 2, 3, 5 in all of these. We can't have another 1 because the 1 is in this row. Obviously, this one's not a 5. So this row is going to need a 5. So this is the 5 for that row. Okay, this is helping. 2, 3 pair. This is our 5 for this box. And then the 5's in one of these 2 cells. This is actually a 4-6 pair. We might as well fill that. I think we're going to have to think about the difference lines. Okay, this is a 2-3 pair. Well, first of all, that's a 1. But also, this tells us we have a difference of 1. So this is going to have to be 2 and then 3. This is not a 3. I don't think I can get to 2 here. If we have a difference of 1 as we move around, we're always going to be going even, odd, even, odd, even, odd, even, right? So this has to be odd, so it can only be a 5. That places this 5 as well. I don't know if there was a different way to do that, but that was fun. This is going to be 2, 3 as well. And then these are both going to be even digits. 2, 4, 6, but neither of them are 2. But they could both be 4 or both be 6. Actually, no, this needs to be between the 3 and the 5. So this is a 4. This needs to be between the 3 and the 5, so that's a 4. Okay. Never mind about being able to be 6. Cool. So this difference line just got completely filled. All of our circles. Okay, well, we already have 2 2s, so this can't be a 2. So that's a 3. Now all of our circles are filled. We get a deet deet doot in the corner. Actually, was my example pretty close to right? I don't know. This one was right, but I don't know if my example... That would be funny if my example was exactly right for those 3s. I don't remember where I put them, though. Let's think about this. We need 1, 2, 3, 6 here. So the 3 is in one of these 2. Oh, the 3 is placed. So these are 1, 2, 6. This isn't a 2. The 2's over here. This is 1, 6. This is 1, 6. That's a 1, 6 pair, giving us the 4 and the 6 here. So the 6 is over here. That puts a 6 down here. You know, we could do 6, 1, 6. That is quite possible. In fact, if these 2 are equal, then the difference line just works. Is that what has to happen? It's not what has to happen. We could do 1, 2. Well, we can't do 1, 2, 3. In fact, let's fill what these can be. These are 1, 2, 6 only. I'm really thinking these have to be equal. So let's pretend this was a 2 for a second. If this was a 2, well, we can't do 2, 2. Yeah, definitely. 2 doesn't work. Because we can't do 2, 2, because this would also be a 2. If we did 2, 1, this would also have to be a 2, and it doesn't work. Yeah. So if these 2 aren't equal, we have to be a sequence, and there's no sequence that works here. So this is not a 2, and these 2 are the same digit. So let's just purple those to remind ourselves that they're the same digit. But this works as a 1 or a 2, because these are the same, so that sequence is just going to work. Now these can't be the same, so this does need to be a sequence. What's left here, though? This is only... Oh, actually, it's 6 and 4. So we're either 1 to 4, but then we could not go back down to 1, and we couldn't get to 7, so that doesn't work. So we're 6, 4, 2 instead. That's a 1. These are both 6s. That's a 1. This is going to have to resolve somehow else. We do get the 2 up here. Let's see, what's over here? The 3 and the 5? We actually know the order. This is a 3 as well. Down here we need a 1, which goes there, and we need a 6. Is this box? This box should be finished. Yeah, this is the 4. And this is the 2. We get the 1 and the 2. Nice. And we're down to 1, 4. And suddenly we're done. Very nice. That was really neat. I liked that, Marty. Very awesome debut to the series. Really nice use of the counting circles and the difference lines. I liked how the counting circles gave us the 2, 3 pair, which then told us what this difference was. That was a neat idea. So cool. I hope you're enjoying the theme week, and I hope you enjoyed this puzzle. And if you did, then why not leave a like, subscribe, and a kind comment below.